Hello students. Today we are going to start with a new topic, that is our introduction to IPv6, right? So this is 5.2 we need to cover today. Okay, so this is a very small topic, right? So you already know about the IPv4, right? So now we need to study now the IPv6, and again with respect to the IPv4 we need to identify the differences in between both, right? So what do you mean by what are the difference in between this particular IPv4 and IPv6, right? What are the different header fields and all that things, right? So first of all we will see what we have covered in our last session, right? So in last session we have discussed with our designing IP addressing plan, right? So because if you see before starting or before doing the routing, right, or using any kind of the routing protocol, you must understand that how the IP addresses can be given to your network topology, right? Then and then only we are going to study the routing and how their different routing protocols are there, and in which circumstances which routing protocol you are going to study, right? And for that purpose we must understand this particular IP addressing plan, right? So we have a different we can call it as an hierarchies over here, right? By which you are going to use this particular IP addresses effectively in your network topology, right? So we have discussed this private and public IP addresses, right? We are experienced that particular network topology with respect to our NAT, right? So that are also we have implemented in by using Cisco packet tracer, right? Then what about the individual location and how you are going to calculate the requirements for that particular IP addressing plan, right? So that also we have discussed. Then we are completed this particular hierarchy with respect to hierarchical addressing, route summarization, what do you mean by CIDR, then IP addressing hierarchy criteria, right? So all these things also we have done. Then we have discussed benefits of this particular IP hierarchical addressing. Then what are the impact for that particular poorly designed IP addressing, right? If you are designing IP addresses randomly, right? If you are just whenever you are doing some scalability in your network, right, and you are just giving or allocating randomly IP addresses to all your network topology, right, then what will the impact of that particular thing, right? And how you are going to you must going to assign or design the IP addressing with respect to that, right? Then FLSM and VLSM also we have studied, right? We have seen that the VLSM is better than FLSM. Then classful and classless so we have discussed, right? So nowadays we are using some classless thing, right? Then some plan with respect to hierarchical IP addressing we have discussed. Then we have seen these particular methods of IP addresses, right? So static and dynamic IP addresses we have seen. We have also I have also demonstrated you with the help of Cisco packet tracer how we are going to configure the DHCP server, and with the help of that how we are going to allocate the IP addresses to all the end devices, right? So that also we have seen. And the next one is static and dynamic name resolution with the help of DNS, how you are going to allocate these IPs, right? So that also we have discussed in our last session, right? So today we will discuss about this particular IPv6, right? So you know that already whatever the limitation with respect to the IPv4, right? So that are we can data overcome in this particular IPv6, right? So this technology will be evolved, right, for the limitation whatever the IPv4 have, right? So that needs to be overcome in this particular IPv6, right? So in this we will study all the overview of this particular IPv4 IPv6 features over there, right? What are the different what we can call one second, I just okay. So so whatever the address, different address format, right? Address types also we need to see today. Then how this particular address assignment will be there in this particular IPv6, right? So with respect to that also we need to think, we need to check, right? And what is the difference in between this particular IPv4 and IPv6, right? So whenever we are going to study the features, address format, address types, and all that things, right? So with respect to that we need to also compare all these things with the IPv4, right? So then and then only you will understand, you will come to know that how these particular IPv4 and IPv6 are working, right? And then we will see to transition strategies, right? So how IPv4 to IPv6 can be transition can be take place with the help of some of the technologies or some of the methodologies, right? So there are three methods, the three strategies over there, right? So by using some dual stack, by using some tunneling, by using some translation techniques, we are going to transition from the IPv4 to IPv6, right? So all these things we need to see today. Okay, so today's lecture is very much short and helpful for you, right? So in these IPv6 features, if you are talking about, right, then you know already the what if you see, whenever we need to give the IP addresses to any kind of the network, right, any kind of the organizational network, right, then you need to think upon their future demands, right? So because in subnetting also we have discussed this in our, whenever you are going to calculate, or whenever you are going to identifying the network requirements for any kind of the organization, right? So at that time also you need to think upon their future demands, right? So whenever you are going to assigning IP addresses to your network topology, right, so at that time also you need to think upon for your future demands of that particular organization in order to scale your network, right? So because obviously it will be improve your mobility, right, or in your campus designing, right? So so this IPv6 will be, it will be combines all the expanded addressing with a more efficient and feature rich header to meet these all the demands, right? So it's having this particular the larger space, so with respect to the IPv6 if we concern, right, and which will be not over there if you're talking about the hierarchical addressing also. So IPv4 is not mean to that, right? So that is where disadvantage is overcome over here, and this particular IPv6 is satisfied all the increasingly complex requirement of hierarchical addressing in this particular organizational network, right? So if you see this whatever our syllabus is also depending upon the Cisco's, right? So Cisco's iOS, if you see, right, so that will also supports the IPv6. Okay, so so we will see what are the different features over here, right? So first of all, if you see the larger address space, right, so IPv6 obviously having a larger address space than the IPv4, right? So you know that already the address space for IPv4 is 32-bit, right? But if you think upon this IPv6, it is 128 bits, right? So this larger addressing space will be helps this particular IPv6 to provide a more support, or the hierarchical addressing as well, right? So it will be a much greater number of addressable nodes can be there, right? Or you can be auto configuration of addresses will be very very simple if you think upon this particular IPv6, talking about IPv6 address spaces, right? So because of larger address space, you are going to use all this hierarchical addressing part, right? You are going to have a number of addressable nodes over there, and also you need to auto configuration of these already addresses as well, right? Because of the larger address space, right? 128-bit. Okay, then the second one is globally unique IP addresses. So obviously every node can have a unique global IPv6 addresses, right? So which eliminates the need for your netting. Okay, so you know already why we are using netting, right? So network address translation we already studied. I have demonstrated by using Cisco packet tracer as well, and this is your NDL experiment number 2 also, right? So in that also we have seen what is the public addresses, private addresses, and all that things, right? But if you see with respect to this particular IPv6, right? So every node which you are going to can use with the help of this particular IPv6 addresses, right? So they are having a unique global IPv6 address over there. So that will be removing your NAT concept, right? Because in NAT what you are going to do is you need to hide the public IP addresses, and you need to showcase your private IP address, and you need to showcase your public IP addresses, right? So that is not the case with respect to IPv6, right? So there is no need of the netting over there if you are concerned with this particular IPv6, right? Then site multi-homing, that means if IPv6 which we are going to use, right? So it will be host to have a multiple IPv6 addresses and allows networks to have multiple IPv6 prefixes, right? So whatever the sites you are going to be connect to the multiple ISPs, right? So it will be without breaking the global routing table you are going to use that, right? So if you see the different ISPs are there which we are from which you are getting joint internet connection, right? So in that they can be used this particular IPv6 prefixes, right? And that will be allows them to have a multiple IPv6 addresses over there. So that is nothing but the multi-homing concept is there, right? Then the header format efficiency. So if you see the header is very simple in case of this particular IPv6, right? And it having a fixed header size that makes the processing more efficient with respect to this particular IPv6 header format if you consider, right? Then improve privacy and security. Obviously you already know the concepts of IPsec and all that things, right? So obviously IPsec is also available with IPv4, right? So that is also available with this particular IPv6, right? So and so the function of this particular is similar to both IPv4 and IPv6 also, right? But in IPv6 this IPsec is mandatory, right? And in IPv6 also some having some security headers, right? So with that respect it will be improved IPv6 with respect to the IPv4 over here with respect to the privacy and the security part, right? Then flow labeling capabilities, right? A new capability which will be enables the labeling of packet, right? Which will be belonging to your particular traffic flows for which the sender requests special handling. For example, if you see the quality of service or for the real-time services, right? You need to it's IPv6 is having some capabilities that will be enable your labeling of that particular packet, right? So which will be transferred from one traffic to another traffic from the sender to the receiver, right? So in this IPv6 that flow labeling capability it having, right? Then last one is your increasing mobility and multicast capability, right? So this particular IPv6 which will be allowing you to IPv6 node to change its location on your IPv6 overall network, right? And it will be maintain its existing connections as well, right? So without breaking your existing connections that IPv6 can be allow you to change the location in that particular network itself, right? So this is nothing but the mobility of your IPv6 packets, right? So the mobile node which will be always reachable through any kind of the addresses over there. So you can be while changing the location of that particular IPv6 packet, right? So you are going to connect with that particular packet as well, right? So there will be no any kind of the break in that particular mobility of your IPv6 if you concern, right? So this is nothing but the one of the also features of this particular IPv6 which will be not there in your IPv4 if you see, right? So then we will see how this particular IPv6 header format look like, right? So if you know that IPv6 addresses which we are going to return in the hexadecimal numbers only, right? So hexadecimal digit, that means nothing but the 16 bits, right? So if you see in this particular example also, right, so I am going to that is nothing but the column hex, if you talking about it, right? So if you see here, these are the some hexadecimal digits over there, right, and some colon in between some of the digits over there, right? So it is nothing but we can call it as an column hex, right? And hex is for your hexadecimal digits, right? And if you see in the sample, I have given one sample over here, right? So you can use, instead of all zero, you can use this particular double colon over here, right? If you see double colon, that is nothing but here 0 0 0 0. Okay, so I just mention here, okay, right? So if you see this particular all zeros address can be written as your double colon, right? So so that's why I have written here the double colon over here, right? So all these things you need to keep in mind, okay? So then we will see what is the packet header format for this particular IPv6, right? So in IPv4 also we have seen this packet header format, right? So in that also the IPv4 is about your 32 bit, right, and this IPv6 is your 128 bit, right? So obviously the header which having in this particular IPv6 having a greater octets, right? So it having a 40 octets. If you seen in the IPv4, it having only a 20 octets, right? So you can see this as having double of your IPv4 octet over here in this particular IPv6, right? So so this IPv6 header is very we can call it as fast is there, efficient is there. So hardware based processing is also fast in this particular IPv6, right? If you are going to compare it with your IPv4, right? So the we can call it fields in this particular IPv6 is also 4 times larger than the IPv4, right? So you know the how strong this particular IPv6 is, right? So this particular IPv4 is also contained 12 header fields, right? So in IPv4 header also having the fixed size of 20 octets, right? And the variable length option over there, then this whenever the increase in the size of that particular IPv4 header, right? So if you see in the IPv6 which will be similar to that particular IPv4 basic header fields, right? So but it requires other field also, right? So it will be contain these are the some other header fields over there with respect to IPv6. So if you see the first header field is your version, right? So this is nothing but a 4-bit field, right? So in IPv4 also it's having a 4-bit, and in IPv6 it's also having a 4-bit, right? But for IPv6 this particular field which will contains the number 6 for the IPv4, right? So that will contain the number 4 over there, right? And here number 6 will be there, right? Then the traffic class, the second one, right, which is an 8-bit field, that is also similar to the one of the field what we can call that yes, the TOS, that is type of service field, right, in that particular IPv4, right? So but here if it is nothing but a 8-bit field, right, and there also that is your 8-bit field in IPv4 it's also, right? So this field which will be useful for tags the packet with the traffic class, right? So it will be useful for the labeling also, right? So these all this function is similar to with if you are talking about this IPv4 and the IPv6 also, right? Then the flow label, right, this 20-bit field is new in this particular IPv6, right? So you are not going to see this particular flow label in the IPv4, right? So it is a new field in this particular IPv6, right? So it and the function of this field is it can be used by the source of this particular packet for to tag the packet as being a part of the specific flow, right? So whatever the traffic you are going to transfer from the sender to receiver, right, what you are going to do is you are going to tag that particular packet, right? And from that particular traffic it is going to be sent from the sender to the receiver, right? So this is a new field in this particular IPv6 if you are concerned, right? Then payload length, this is also a 16-bit field which will be also there in IPv4. You already know about this, right? Then next header, right? So it will be the value of this 8-bit field, right? So this is next header, the 8-bit field, which will be determines the type of the information that follows the basic IPv6 header. If you see, right? So whatever the TCP, UDP, whatever the transmission control protocol, user datagram protocol, right? Or it can be your extension header, right? So this is also a similar field are there which is in also in IPv4, right? Then next one is a hop limit, right? This is also a 8-bit field, right? So which will be specifying how many maximum number of hops that the IPv6 can reserve, or sorry, the IPv6 can transfer or can be travel, right? So it is also a same field, just a name is changed over here, right? So if you are concerned with the IPv4, right? So in IPv4 the field which we can call it as time to live, right? So that is TTL field, right? So just here it is nothing but your hop limit. Okay, so that also you need to check with this, right? Then the source addresses, right? So obviously this particular field is having 128 bits, right? So 128 bits, nothing but your 16 octet over here, right? So it is it will be identify the source of the packet, right? Then the destination address, it will be also similar. It is also having a 128 bit, that means 16 octets, and it also identifies the destination of the packet, right? Then your extension headers, right? So it will be extension headers if any data portion of that particular packet which will be follows the other 8 fields, right? Or if extension header, if it is not fixed, right, then this particular total length of that particular extension header chain is variable, right? So it will be useful for extension for headers particularly, right? Then we will see this particular IP addressing types, right? So you already know this particular unicast, anycast, and multicast, right? So unicast, that is nothing but your one-to-one addressing, right? So it will be also similar to your IPv4 addresses, right? So IPv6 unicast addresses is for your single source to send data to the single destination, right? That means only one-to-one communication over there, right? And whatever the packet you are going to send to this particular unicast IPv6 address, it will be goes to the interface identifying by that addresses, and that particular IPv6 address space can be encompasses the entire IPv6 address range, and also having some range of their which will be used for your multicasting addresses, right? So if you see in this particular anycast, right, the second address types of this particular IPv6, right? So it is nothing but the one to your nearest, right? So whatever the IPv6 which will be anycast address is a new type of the address that will be assigned to set as interface to on a different devices, right? So this anycast addresses which will be identifies multiple interfaces, right? So whatever the interfaces over nearest or close interface to that particular packet, right? So according to that it will be obviously determined by the routing protocol also, itself, right? And from that it will be identified the anycast addresses, right? And therefore all the nodes with which having the same anycast addresses should provide the uniform service, right? So that must be obviously that is the case, right? So because it will be having some communication with the some nearest interfaces, right, or close interfaces, right? And therefore it will be also providing the uniform services over there, right? So this is also new field, new we can call it as a type of the addresses over here, right? So this anycast addresses it will be not used as a source address of the IPv6 addresses, IPv6 packets, right? So that you need to keep in mind. And the last one is your multicasting addresses, that is nothing but your one to many, right? So it will be also similar to your IPv4 multicasting, right? So whatever the IPv6 multicast addresses, you need to identify it on a set of that particular interfaces, right? So it will be obviously on a different devices, right? And this packet which you are going to send to this particular multicast addresses is delivered to all the interfaces which will be identified by the multicast addresses, right? So that is also you need to keep in mind. Okay, then we will see now the differences in between this particular IPv4 and the IPv6, right? So if you see whatever the protocols or whatever the communication domains are there with respect to IPv4 and IPv6, right? So there are some differences also, right? So for example, we have discussed that is address length of that particular IPv4 is 32 bit, then the IPv6 address length is your 128 bits long, right? So this is also one of your differences, right? Then obviously IPv6 packet header is different from this particular IPv4 address packet header, right? IPv6 header is longer and simpler if you are compare with the IPv4 there, right? Then IPv6 has no concept of broadcasting addresses, right? So instead of that, it can be using as your multicasting addresses, right? So as we are discussed just now. Then the routing protocol which will be must be changed to support native IPv6 routing, right? So these are some basic differences in between the IPv4 and the IPv6, right? So with respect to your examination, right? So you must know what do you mean by IPv4. You must know what are the header fields, all the header fields, their length and all that things, right? Also with respect to the IPv6, their header length, their length of each and every fields, right? And what are their differences in between this particular IPv4 and the IPv6, right? So all these parts you must know. Okay, then we will move towards this particular IPv6 to IPv4 to IPv6 transition techniques, right? So this particular transition which we are talking about, right? So obviously because if you see whatever we have with respect to our IPv4, right, it already the equipments and all that are there, right? But if you wanted to move from IPv4 to IPv6, so obviously the equipment whatever we have and existing infrastructure whatever we have, right, all that things must be upgraded, right? You need to obviously use the upgraded equipment in order to use this particular IPv6, right? And obviously it will be taking several years, right? And so that part what we are need to do is we need to transition techniques. We need to identify some strategies over there which can be translate this particular IPv4 to IPv6, right? And after that we are going to get that particular thing, right? So in order to do that, right, so we have some different mechanism, right? So first of all we will see these are the three mechanisms over there which can be used to the transit in between from the IPv4 to IPv6, right? So first of all if you see the dual stack, right, so both IPv4 and IPv6, right, which will be stacks run on a system that can communicate with both IPv6 and the IPv4 devices, right? So what you are going to use that you need to use all these types of the components, all these the equipments or all these things which will be what we can compatible with this particular IPv4 and the IPv6, right? Both the devices, right? And it will be must be communicate with the both the devices, right? So that you need to think upon. Then the tunneling, it will be uses encapsulation of IPv6 packet to traverse the IPv4 networks and vice versa, right? So you know the concepts of tunneling, right? So if you one attack is there called a wormhole attack, right? If you go and study with the wormhole attack, right, so it will be also happen in your tunneling part, right? So when you are going to encapsulate that particular IPv6 packet, right, and then you are going to transfer that IPv6 packet to this particular tunnel, and from that tunneling you are going to dispatch that particular IPv6 packet, and at the end it will be it will be received by that particular IPv4 networks, right? So what you are going to do in this tunneling, so two IPv4 networks will be there, right? And from within that particular IPv6 networks, you are using this particular encapsulated IPv6 packet, and at the either side you are receiving that particular at the IPv4 networks, right? So this is a tunneling part, and the third mechanism is your translation mechanism, right? So one protocol to the other protocol, the communication will be happen in these particular two networks, right? So that is the concept of your translation, right? So we will see one by one in more detail with these three transition techniques of IPv4 to IPv6, right? How it can be done, the transition in between these, right? So just we'll go one by one. So if you see in this particular first technique or first mechanism, that is dual stack, right? So the dual stack node, it will be enables this particular IPv4 and IPv6 stacks, right? So as I already mentioned, I already told you, right? So the applications which we are communicate with both IPv4 and the IPv6, right? So if you see, the application is having this particular both communication with respect to this IPv4 and IPv6 stacks, right? So IP version choice is based on this particular name lookup and the application preferences over here, right? So this is the most appropriate method for your if you're talking about your campus network, or if you're talking about your access layer networks, right? So whenever the transition can be happen, right? So it will be preferred technique to transition in to this particular IPv6 technique, right? So if you see in this particular dual stack approach, right, the support for this maximum number of applications, right? So whatever the OS you are going to use, right? So it must having the support for this particular IPv6 stack, right? So if you're talking about Linux, Sun, Solaris, Windows, XP, Vista, whatever it may be, right? So all having the must support for this particular IPv6 stacks, because whatever the application you are going to use over there now, so there are communication in between this particular both the stacks, right? So IPv4 as well as IPv6, right? So this particular IP version choice is based on that particular name lookup and application preferences, whichever applications you are going to use, right? So this is nothing but the concepts of your dual stack transition techniques, right? So in order to use that, you need to first of all check whether whatever the OS you are going to use, that will be enabled for this particular communication of dual stack in between IPv4 and IPv6, right? So that you need to take care of that, right? So this is one dual stack transition mechanism over there. Then we have the tunneling transition mechanism, right? So purpose for this tunneling to encapsulate this particular packages, right? For that another part, so whenever you are going to transition in between this particular IPv6, right, this tunneling which will be encapsulate that particular IPv6 packets, right, and IPv6 packet into your IPv4 packets, right? So if you see in this particular figure, right, so it is using some over here some overlay tunnels over here, right? So it will be isolated this IPv6 networks, and which will be communicate without having an upgraded IPv4 infrastructure in between them, right? So both router and host can use tunneling over there, right? So if you see here we have and some dual stack routers over here, right, and which and some IPv6 host also over there, right? So which will be connected to this particular IPv6 network, which having some IPv6 header and data in their header format, right? And after by using some of the tunneling for this particular dual stack, which are compatible with this particular IPv6 and the IPv4, which will be using this particular tunneling part, and it also appending over here, if you see the IPv4 header in that particular IPv6 network, right? So and it will be used by this particular dual stack host, right? So how this particular tunneling will be done, you just check, right? So in here also, if you see the same thing, whatever we have seen here, it will be also same here. We are going to check the dual stack router we are going to use. We are using some IPv6 host, and in between both we are having some IPv6 network over there, which having some IPv6 header and IPv6 data. And by using this particular dual stack routers, right, we are having we are appending this particular IPv4 header to that particular IPv6 header format, and then this particular transition can be happen, right. So all these thing we are going to do with the help of that particular tunneling part, right. So so if you see there are some different technique which will be available for this particular establishing a tunneling, if you talking about, right. So someone the first one is your first of all the manually configure, right. So you, in order to configure this particular tunnel manually, right, you need to source and tunnel destination are manually configured with the static addresses, right. So in static we already seen, right. So what you need to do, the administrator needs to manually assign or configure the IP addresses over there, right. So in these particular tunneling also, what you need to do is you need to configure with this particular IPv4 or IPv6 addresses over there, and manual tunneling can be configured in between border routers, between this particular routers and the host, right. So if you see here, these are nothing but the border routers, right. So in between the border routers and the border hosts, what you need to do is you need to configure your manual tunnel over there, right, by using some IPv4 or IPv6 addresses, right. So that also you need to keep in mind, right. So that is nothing but your manually configured. Then the semi-automated, right. So if you see in semi-automation can be achieved by using tunnel broker, right. So you should be use some web-based services to create this particular tunnel, right. So this tunnel broker is a server on that particular IPv4 network that receives this tunnel request from the dual stack client, and then that can configure the tunnel on that particular tunnel server, or which can be we can also call it as a router, right. And after that it will be associate that tunnel from the client to one of the tunnel servers, and then it can be used, right. So with the help of some tunnel broker, they are going to achieve this particular tunneling part, right, in short. So right, so that you need to understand. So in semi-automated, what happen exactly, the tunnel broker can be used to establish tunnel in between the sender and the receiver of the border router, or we can call it a tunnel server over there, right. And then the third one is your automatic, right. So various automatic mechanism also over there, right. So if you see the IPv4 compatible mechanism is there, which will be dynamically use this particular IPv6 compatible IPv6 addresses, right. So because it does not scale, this particular mechanism is appropriate only for the testing, right. So it not having that scaling property as good as, right. So just because of that, you can just for testing purpose we are going to use this particular automatic configuration part with respect to this particular tunneling as considered, right. Then we having this third one, that is translation transition mechanism, right. So in that if you see this dual stack and tunneling techniques which we are going to which we already seen now, right, that can be manage the interconnection of IPv6 domains, right. And for this particular legally equipment that will be not be upgraded to IPv6, or for some deployment scenarios, techniques are available for connecting this IPv4 only nodes to this particular IPv6 only nodes, right. So at that time, using this particular translation and extension of NAT techniques, if you see, right. So whatever the NAT we have already studied, right. So in that NAT also we have seen this particular translation points, right. So this particular translation points at which the translation in between the IPv6 to IPv4 or IPv4 to IPv6 can be carried out, right. So these techniques or these addresses whatever we have seen, this is similarly your NAT protocol, right. So network address translation protocol we can call, right. And in that also that particular technique will be used, right. So this is nothing but your translation transition mechanism, if you see, right. So in this we will see this how this particular IPv6 are there, and why we are not going to use this IPv6, right? Because of some upgradations are required with respect to your equipments and all that things, because nowadays most of from the several years we are going to use this IPv4 only, right? And if your equipment is not compatible, or it will be not familiar with that particular IPv6 techniques, right, then all the equipments whatever you have in your existing infrastructure, right, all that you need to upgrade it with this particular IPv6 enabled components, right, and which will be very tedious task, right, and which will be also very costlier, right? So for that purpose we are not all the organization whatever nowadays using IPv4 techniques, that are not shifted to this particular IPv6. That is the reason, right? So but we must know, right, what is the difference in between both, right, how the header phase and all that things, right, what are the different transition techniques also there, which will be nowadays we are going to use for translating, or by using some tunneling, or by using some dual stack technique, transition mechanism, right? So all these techniques which will be used, right, for the transition between IPv4 to IPv6, right? So I hope you will understood this, right? So so what we have studied today, right? So we have discussed the introduction to IPv6. In that IPv6 features we have first of all discussed, right, whatever the features we have. Then IPv6 address format we have seen, right? Then IPv6 address types also we have discussed. With respect to IPv4, right, we have compared with IPv6 and IPv4, right, what are the different length of bits, then how this particular header formats are there, right, all that things we have discussed. And then the transition strategies, right, so how we are going to convert this IPv6 to IPv4 to IPv6, right? So by using some dual stack technique, using some tunneling technique, using some translation technique, right? So all these things we have discussed today. Okay, so after that we will move towards our routing, right? So in next session we are going to see the routing thing, right? So in order to you know already that in order to complete your project, mini project also, the routing part is very much important one, right? Because if you see we first of all studied this particular IP addressing plan, right? So after IP addressing plan you must be switched from the routing part, right? In that routing also we have discussed some point, that is your static routing, dynamic routing, right? So I have also listed out some of the time OSPF, EIGRP, RIP, right? All these are the some routing methodology technologies, right? So we will see in next lecture what do you mean by the routing, right? What are the different types of the routing? For example, static routing, dynamic routing, then interior routing, exterior routing. There are different protocols over there, right? Then distance vector routing, link state routing, then hybrid protocols are there. Then what are the different metrics on which this particular path of the routing can be decided, right? So all these metrics also we are going to study. Then routing protocol convergence also we need to see, right? Then the flat routing protocols, hierarchical routing protocols, that also we need to see, right? So all this related to your routing part we are going to see. And if you see in our experiment list also, right, so the routing and the static routing also we have one experiment, right? On dynamic routing we have 3 experiment, that is for RIP we are having one experiment, for EIGRP we are having one experiment, for OSPF we are having one experiment, right? So the total 4 experiments we have on this particular routing part only, right? And 2 experiments we already done while theory sessions, right? So first of all, one is your DSCP and the second one is your netting, right? So both I have demonstrated you, right? Now this particular 4 experiment you need to go through that, right? So I'm not going to demonstrate you all these four because the recordings already shared in the drive, right? So you just need to go with that. Okay, how these particular routing protocols can be configured, how they are implemented in the Cisco packet tracer, right? That all you need to see, because if you see in your mini project also, whatever the topology you are going to create for your topic, right? So in that also you need to include all these routing protocols over there, right? You need to decide which routing protocol is best suited for your topology, with respect to your topology, right? That you need to identify first, right? And how you are going to identify, when you are going to identify, when then and then only when you are able to know the differences in between all these protocols, or all these routing protocols over there, right? Then and then only you are going to use, because in if you see the examination for this particular subject is totally based on your mini project only, right? So whatever you are going to do in your mini project, right? So the question will be asked on that particular thing only, right? So for example, if you are using one static routing protocol instead of the dynamic routing protocol, right? Then the question maybe ask you why you are using static one, why not dynamic one, right? So you must have the reason with you, right? Because if your network is very very small, right? If you are using only 4 to 5 internet networking devices, right? You are easily remember the IP addresses and all that things, right? So why the dynamic routing protocol then required by you, right? So the static can be work for you, right, in that case, right? But if your network is very very large, right, and at that case if you are using this static routing protocol, right, then the question may be asked again, same question, why you are going to use this static and why not dynamic one, right? So also at that time also you must have the answers, right? Why you are using all these kind of the things, right? And for that the differences in between the protocols must be know, right? But the fields you must be know, how this particular thing can be configured on through CLI, command line interface, right? All these commands also you must know, right? So that's why I have recorded all the experiments in before time, and I have uploaded that, because that will be helpful for you in your mini project, right? So because at the end of this particular thing, I just wanted to see your mini project only, right? And that is nothing but your end product. Okay, so all these techniques whatever we are going to study now, right? So all these can be useful for your mini project, right? So let's stop it today. Okay, we will start this particular routing protocol from your next lecture, right? So it will be required me to complete this routing part in a two sessions, right? So after that we are end up with this particular chapter, right? So from the 2 sessions I will require to complete it. Okay, so after that we have only one chapter left, that is chapter number 6. So let's stop today. Okay, so there is no test today. Okay, thank you for joining.